Jack Silverman, and this is my William ether synthesis experiment. Here's what I'm going to be using. Since I'm in my house, I have very limited stuff. So this is sugar. This is going to be the 0.5 grams of bromotriphenyl methane. I just have water for 5 milliliters of the ethanol. I don't have an Earl Mile flask or a round bottom flask, so I'm just using this cup, so this is going to be acting as our flask. This is my ice bath. This will be the vacuum filtration, and this is my hot plate. In addition, I have 2 TLC strips and my stirring rod. So to start off, obviously I don't have any metric measurements, so this is going to be very rough measurement, but you're supposed to be putting in 0.5 grams of the bromotrimethyl methane and then 5 milliliters of ethanol. So what you want to do first is that you want to mix them all together. So we're going to put in a little bit of the ethanol, and we're going to take some of the bromotrimethyl phenyl methane. So we're going to put that in there. And then what we want to do after that is get our stirring rod, which is just a Slater straw that I snatched before going off. I'm just gonna mix this together a little bit. So yeah, perfect. And then after that gets going, we're gonna get our hot plate, quote unquote hot plate, and place it out in there to increase, which it should be running at, if we were in the lab, it'd be running at 75 degrees Celsius. So as we see, there's the quote unquote bromo triphenyl. Actually, it's doing a pretty good job of dissolving triphenyl methane. Oh, it did dissolve. So if it didn't dissolve, we would add more of the solvent of the ethanol in this, and if there's too much of the ethanol or the solvent in there, you would just keep heating it on this hot plate until it evaporated and stuff. But it's looking pretty good. So, since it's getting all dissolved in the solvent, we would keep this on the hot plate for about 15 minutes, keep stirring it with our stirring rod like this to help it get all in there. But then after 15 minutes, we would take it off of the hot plate and we would do some TLC on it. So to make sure the reaction is combined, and to see if it's different than the bromo triphenyl methane, we would take the TLC, with the TLC strips. So right here, I already made already placed a bromo triphenyl methane on here. So what we're gonna do is that we're just gonna take a little toothpick, which would act as our little tiny syringe that we used beforehand. We put a little, drop it, you can't really see it, but we put a little bit of it. Put a little bit on here, so get in there. So after that, we take this with the strip. I don't have this like a big thing of solvent. What we do is that we put it in there, dunk it, give it a dunk, and then actually we leave it in there, and then the solvent would travel up the TLC strip, and it'd go up to a certain point, and we'd stop it, and we'd mark it. I've already marked it right here. So then what we do is to see if this is the same as our current solution is the same as the bromo triphenyl methane, is that we'd put it under UV light and mark how far these spots have traveled up with putting the solvent in here. So, this is what it would look like after we put on a UV light. So this is the solution we just created under the hot plate real quick. And this is the original bromo triphenyl methane. And since the spots basically moved up the same, a reaction hasn't occurred entirely yet. So what this tells us is that it hasn't completed in its entirety. So we're gonna put it on our hot plate for a little bit longer. We want it on the hot plate for a total of 30 minutes, so we've gone 15 minutes, so that's another 15 minutes just stirring it and keep stirring it. So let's say that's been 30 minutes after including before the TLC. So we take that off, and let it cool to room temperature. So at this point, you know, some recrystallization should be occurring as it's cooling down more and more. But if it's not, what we can do to help aid the process is by scraping the sides of the flask to help aid it some more. So after it's cooled down to room temperature completely, after going on the hot plate, we put in the ice bath to allow it to crystallize even further. So we let it do that, and we keep doing that until we see all the crystals form in there. So there's no definite place to have it placed in the ice bath for, but just until the crystals form. So after that's done, you know you can't see it, but let's say the crystals formed in there already. So we take it out, we let it cool to room temperature again, and at this point there would be crystals floating around in there, and we'd be able to see actual solids in there. So from that point, the way we'd separate it is we'd be using a vacuum filtration system. So what I have isn't that fancy, but I just basically have a coffee filter with a glass mug. In the lab, we'd have this. It'd be like a similar kind of filter, except it'd be more advanced. And then we have like a little tube down here to suck out the air to force the liquid out more and more. So from this point on, what we want is to separate the solid from the liquid in there. So, you know, we basically just pour it in our vacuum filtration. So it's filtering all the liquid from the solid. So let's say it's still going in there. For the most part, there's still some water in there, but for the most part, it's gone. Yeah, for the most part, the water's gone through, and the solid would be in there, and the crystals would still be in there, so we'd catch it like that, and we'd have to allow the crystals to, you know, basically dry, so we could actually like collect it. So what we do with this once it's dried is that, you know, we get it out, we scrape it out of the filter, place it on a plate, compute the yield of it, like the amount that we actually managed to collect, and then the percent yield, which is the amount, it's just the percent of the amount that we could have actually gotten. And then we do NMR, we could do NMR, and then we also do another TLC, another one of these slates to make sure the reaction actually occurred fully, and we got a completely different solution, or a completely different solid than the bromine triphenyl methane. So yeah, this is how you do the William Ether Synthesis Lab, and thank you and bye-bye.